second ion here, NO3 1 minus. Let's start off by figuring out how many valence electrons we've got. How many does nitrogen have? 5. And you know that because? Periodic table, group 15. Periodic table. Okay, so nitrogen, 5. We only have 1 nitrogen. Oxygen has got how many? 6. How many oxygen do we have? 3. So that gives us 18. That puts us at 23. And are we done?
Nope.
No, this is a charged polyatomic ion. It's got a -1 charge, so we have to add 1 valence electron. So we have 24 valence electrons. Okay, let's figure out how many octet electrons, how many everything wants. Are any of these exceptions to the rule? Are any of them weirdos? Nope. They all want a full 8. How many atoms do we have? 4 atoms, 1 nitrogen, 3 oxygen. So 4 times 8 gives us 32 octet electrons. Our bond electrons are just octet minus valence, so 32 minus 24. How many electrons will be involved in bonds? 8. Okay. Bonds are just bond electrons divided by 2. 8 divided by 2, how many bonds are we looking at? 4. Which tells us we have a double bond. Isn't this beautiful? I love this system. So now we know the least electronegative will be in the center, or the thing we only have 1 of, which is nitrogen. So let's put our nitrogen in the center. We'll start off with just arranging our oxygens around it. Well, that's great, but we have 4 bonds. So one of them has to be a double. Now, let's look at our unshared electrons for placement. That would be our valence minus our bond. So, oops, valence E minus bond E. We have 24 minus 8 gives us 16. So, 1, 2, 3, 4. 1, 2, 3, 4. 2, 4, 6, 8. 10, 12, 14, 16. Are we done? It's an ion, so what do we have to do? Brackets and charge. Are we done now? Heck no! We got to show resonance! 2 more times! Now you don't have to go back through and figure out all that other stuff, because we know we have the basic structure correct. We just have to move that double bond around. So we draw our double-headed arrow, draw our brackets, things we want to check whenever we're done drawing one of these. Is every atom satisfied as far as octet is concerned? This one's got 2, 4, 6, 8. This one has 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Okay. Yes, ma'am? The double bond is where they're sharing 2 electrons. Yes, that's why there are two lines there. Each line indicates a pair of electrons that are shared. So this line represents 2 electrons. This line represents 2 electrons. That represents 2 electrons. That represents 2 electrons.
What do you do if, like, it doesn't come out to each atom getting an octet?
then you've got a problem. Then you go back and fix it.
I mean, like, what if, like, are there going to be any,
Other than your exceptions, boron and hydrogen, everything will get an octet.
okay.
The only other exception would be something like sulfur hexafluoride. Sulfur will end up with, I mean, there's no way that you can have an arrangement that doesn't involve sulfur having more than 8 electrons around it. But that's okay because it's fluorine, it's very electronegative, it's drawing the electron cloud off of sulfur. We'll look at some of those as we go.
So we're not going to get like a molecule where where each thing doesn't get 8 electrons.
No. No, you'll, for the most part, you will have things that satisfy octet.
Okay.
Okay, let's cut this video off. You'll have